Hello everyone, I am Zach Peterson. Welcome back to my channel. This video is going to be answering all of your questions on my Altium Academy videos, and the topic of the video is PCB footprints. This is the second Q&A video we are doing on PCB footprints, and of course, after some recent podcast episodes, I started getting a lot of great questions about PCB footprints. Let's go ahead and hop in and get started. This first question comes from the older solder mask expansion deep dive video, and this question comes from superfan Peter Sage. Peter writes, "Oh my god, first! This is where knowing your fabricator's registration capabilities becomes paramount. Design within them and Bob's your auntie. For those of us who go to the rapid prototyping fabricators, this has to include choosing component footprints that won't challenge their capabilities. Another consideration is if you need to route traces under the solder mask slivers between pins." Not really a question, more of a comment from Peter, but he does bring up a couple of really good points about solder mask expansion, which I think a lot of folks don't think about, and that is the size of the leftover solder mask sliver. If you take a look here on screen, you will see that we have 3 footprints, all for the same component, from my podcast episode with Elizabeth Bustamante, and you can see what the solder mask sliver is just by looking between adjacent pads. You can see that within these footprints, you'll have some leftover solder mask between the pads due to the solder mask expansion around each of these copper pads in these footprints. Now, how big does that solder mask sliver actually need to be? And do you need to have a different value when you're working with 2 pads in the same footprint versus between 2 pads on different components? Well, one of the values that I've been told from a PCB fabricator that I've worked with for a long time is to just use a blanket value of 5 mils everywhere in the PCB layout. I've had other PCB fabricators tell me that 3 mils is an appropriate limit, and I usually set a value of 4 mils when I'm working in a PCB layout. Now, you'll notice that Peter Sage also brought up routing in between pads underneath the solder mask sliver, and that's really something that you encounter in a BGA, but not something in, like, for example, a QFN or a QFP package. When you have a fine pitch package like a QFP or a QFN, there's really not a lot of room to route a trace in between the pads on that package. And you're going to have a solder mask sliver value of maybe, for example, 3 mils, depending on the value of your solder mask expansion. Now, a value of 3 mil for a solder mask sliver is basically going to be the same limit that you'll have on the PCB trace width. So it's not really going to be practical to route in between pads that leave behind a 3 mil solder mask sliver. In addition, you would need to maintain some required clearance between the trace and the nearby pads, so I don't really think that's an applicable situation in most designs. But in any case, whether you're working in Altium Designer or another CAD tool, make sure to set an appropriate solder mask sliver value that allows you to get components reasonably close together while still ensuring you have a solder mask dam between SMD pads in your design. This next question comes from the Footprint Layers video on Altium Academy, and this question comes from Key Samuel. Key writes, "Thank you, I am having a different requirement. I have to make a PCB footprint of a patch antenna with slots and an internal coupler, which are spanning in different copper layers, specifically a total of 3 copper layers. How can I create a PCB footprint for such a component? Kindly provide a solution to this requirement." Now, I'm not aware of any PCB design software that allows you to create a footprint with copper in 3 layers. One of the big reasons for that is, of course, some PCBs will only have 2 layers, so what would you do with the 3rd layer in that footprint? I think one solution to this problem is that you could use 2 of the PCB layers and fill them with the copper that you need, and then you could have a 3rd layer that's a mechanical layer, and that mechanical layer could basically give you all of the information that you need to define copper in one of the additional layers in your PCB layout. You could then basically just copy that mechanical information into one of your copper layers, and there's your 3rd layer for your PCB footprint. Now, there is another way that you could do this in Altium Designer without having to mix copper layers and mechanical layers in a PCB footprint, and that would be to use the design reuse feature in Altium Designer. Altium Designer allows you to define schematic and PCB layout sections that can be reused across designs, and you could do that with this patch antenna footprint that's being referenced in this question. Make sure to check out the video link in the description to learn more about that feature in Altium Designer. This next question comes on one of the Altium tutorial videos on the Altium Academy channel. And the question asks, what other component layers should one add? What parameters must one contain in the schematic symbols? Well, I'll address the symbols question first. I think there are really only two parameters that are absolutely mandatory in schematic symbols, no matter which CAD program you're using. The first is the name of the manufacturer of the part, and the second is the manufacturer part number. Now, of course, you could include a lot of other parameters in a schematic symbol. You could include technical information, you could include packaging information, you could include supplier information. It's really up to you. But in order to generate a BOM from your schematic, you really need to have those two pieces of information, the manufacturer and the manufacturer part number, because that's what's going to be easiest to use to generate that bill of materials, so that way you can quote the design for assembly. Now, the second part of the question, or I guess the first part of the question, what component layers should one add in a footprint? Well, of course, in a footprint, you need your copper layers, and the copper layers will have automatically generated solder mask and paste mask layers, and then you'll have silkscreen layers. So that's a minimum of 4 layers on each side of the board, and if your footprint uses both sides of the board, such as a through-hole component, it could have a total of 8 layers. So I think that's the minimum viable number of layers that you need for a PCB footprint. Now, there are additional layers that will appear in PCB footprints. One of these is the assembly layers, which could be assembly top and assembly bottom. That's going to appear in an assembly drawing that you generate from your PCB layout. Another layer that you'll find in a lot of PCB footprints is the courtyard layer. The courtyard layer basically tells you the component outline plus some margin. That way you know how much clearance you need to enforce around that package for your component. Depending on your source for PCB footprints, you will see different uses of different layers, and you'll see different information in these different layers, so don't expect every component source to have all of this information standardized. Now, this is one of the issues I talked about with Elizabeth Bustamante and Kristen Aguiar in some recent podcast episodes. Check out the video description for links to those episodes. This next question comes from the bottom Terminated components video, and this question comes from superfan Super Jim. Super Jim writes, via in the footprint is a pretty bad idea unless your designs are always such low density that no traces need to pass beneath. Also means that you might end up with different size vias in your design. I often get PCB suppliers querying vias in pads where the mask is closed on the bottom side. They either want to open the back or print mask over the hole on top. Now, what Super Jim is referring to are some of the footprints that you see here on screen. And these are footprints that I actually found inside the manufacturer part search panel. You can see here in these footprints, we actually have vias inside the pads in the footprint. So the footprint data actually contains vias embedded in it. I was really surprised to find that inside the manufacturer part search panel. Now, there are a number of reasons that this is a bad practice, and Super Jim mentioned one of them, which is it basically takes up all that space for routing. And you might say, well, of course, you could just delete one of the vias out of that footprint, right? Well, sure, you could, but you have to go back and make a copy of the footprint and then manually delete the via, reassign that footprint to that schematic symbol, and then update the PCB layout. And it's a big pain to do that every single time you need to eliminate a via from a footprint. A better option for dealing with vias on die-attached pads and these types of components is to leave the vias out of the footprint and just place them manually in the PCB layout. That's going to give you a lot more control over where you get to route on those internal layers. You can also adjust the spacing and the number of vias. You can adjust the via hole size, and that's going to allow you to make room where you need it for any traces that might need to pass underneath that component on an internal layer. You can also imagine what happens when you have a large number of these types of components in a design and they all have to have vias in that die-attached pad for thermal handling. That takes up a lot of room on those inner layers. So for example, maybe you want to use blind vias to connect to a plane on layer 2 or layer 3 in this design in order to pass that heat into an inner plane. That's a great way to make that connection to a plane to help with heat dissipation without taking up space on any any of those deeper internal layers in the PCB. This next question also comes from the bottom terminated components video, and this question comes from Sean3994. Sean writes, interesting that you mention using tented vias to prevent solder flow through to the backside of the board. I would think it is best practice to open the solder mask on the backside of the via to avoid possible blowout. Minimizing this opening should keep the amount of flow through to acceptable levels. So normally I recommend closing the solder mask behind a bottom terminated component in order to prevent the solder wicking through to the back side in the case where you've basically placed vias all over that die-attached pad and then you fully opened up that solder paste mask, and that's going to potentially allow solder paste to then flow through to the back side. Now, I usually recommend tenting those vias when you have components also placed nearby those vias on the back side of the board, and they could then be at risk of making contact with that flowing solder, potentially creating short circuits. But the best solution is, of course, to chop that big solder paste mask opening on that big die-attached pad into smaller segments, usually into a set of 4 squares. That's going to allow you to place some vias in that die-attached pad while still leaving some space to the solder paste mask opening, and then that's going to help prevent solder flow through to the backside of the board. Now, Sean also mentioned blowout during reflow soldering, and one of the reasons that you would keep a via open, or at least keep a via nearby that's open and untented and unfilled, would be to allow some of those exhaust gases to then move through to the backside of the board during soldering. During reflow soldering, the solder will create some exhaust gases, and those gases could get caught underneath a larger integrated circuit and possibly cause it to skew or lift during soldering. Having an open via nearby allows those solder gases to escape and helps prevent this potential assembly defect. So in this situation that I've mentioned, obviously there's a lot of factors that you need to balance. In my opinion, I think just limiting the size of the paste mask opening to these individual square sections is going to be your best bet for most designs. This next question comes from the When to Use Via in Pad video. Check out this guy on screen. I look like I'm still in my 20s. And the question asks, how did you fan out your 0.4 millimeter BGA? Well, a 0.4 millimeter BGA refers to, of course, the pitch between the pads and the balls in that BGA. Now, a 0.4 millimeter BGA is going to have small enough pitch that you're basically going to be unable to put a standard mechanically drilled via in between the pads or in between the balls on that BGA package. And so the result is that you'll be forced to put the via for that package in order to reach the inner balls in the pad in the PCB footprint. Now, what about with a laser drilled via? Fire the laser! Well, with laser drilled vias in a BGA fan out, if the laser drilled via has a small enough diameter, you might be able to fit it in between the pads in the PCB footprint so that you could do a dog bone fan out. Maybe you can do that with 0.4 millimeter pitch BGA. But generally, once you get down to 0.4 millimeters or 0.35 millimeters, like in the NRF52 wafer level chip scale package, you're gonna be forced to do via in pad, whether it's mechanically drilled vias or laser drilled vias. The reason is that the pad pitch is just too small to put most vias in between the pads in that PCB footprint. Using those very small diameter laser drilled vias, such as, for example, a 2 mil via, is then going to also require that you use a 1 mil thick outer layer film for that buildup layer supporting that blind via. All that's doing is adding costs to the board, and if your only reason for doing it is avoiding via in pad, I don't think that's a very good reason. So I would say use the larger diameter via because it's going to be more reliable, it's going to cost less to fabricate, and your fabrication house, if they can already handle a larger diameter laser drilled via, is certainly going to be able to handle via in pad with laser drilled vias. And this final question of our Q&A session comes from the Mastering Pad and Via Templates video. This question asks, thank you very much. I actually switched from Fusion to Altium because of you. Super helpful video. Well, thank you very much. It would be awesome if you could make a video about working with libraries in Altium, creating, copying, editing parts, and especially how you handle this in practice. And the big question, One library to rule them all, or does each project get its own library? Would love to hear your thoughts. This is a really great question about library management and footprint management. And I think it really depends whether you work at a big company or you work for a design services firm, or if you're a freelancer. So there are a number of different approaches that you can take. I will tell you, as someone who runs a design services firm, we're always making libraries on behalf of clients, and we're pulling from a central library to do that. So we're really taking a combination of approaches. We're making one library for an individual project, but we're pulling from our own library in order to be able to do that. This topic is deep enough that I'm not going to be able to answer it fully in this video, so I'm going to save this topic for another video. Make sure to hit the subscribe button and you'll see when that video comes out. Thanks for watching this video, everybody, and thank you for leaving all of the great comments and questions on my videos on the Altium Academy channel. And for those of you who are subscribed, thank you so much for leaving all the great comments and questions on my videos on this channel. Make sure to hit the subscribe button, and I'll see you in the next video.